I'm just guessing that I'm live. Okay, just let me know if I'm live or not. Just let me know. Okay, whoever has joined. Just let me know. Okay, whoever has joined. Okay, so it's completely like audible and visible. Okay, so I'll just wait for a few seconds, like till the contest gets over. Till then, like, let me just cover up my screen for now. Okay, so yeah, I hope you can see me. Let me refocus it. So okay, uh, till the contest gets over, I want you guys to comment out that what do you feel about the contest? Like, how was the contest for you guys till now? The contest still not over yet. So let me do one thing. Let me just quickly post the link on Discord. Okay, so people may join it ASAP. Join ASAP. I also need to like work on the thumbnail thing. Okay, so I also need to work on thumbnail thing. So I'll just connect it to my phone and make the thumbnail real quick. But before that, I think so. Let me tell you guys that I have done the questions from A to F, G, H, right? I have done all the questions from A to F. Okay. Right now, I'm working on this G question. Okay. Right now, I'm working on G, which I feel like I won't disclose anything like what I think about it. For now, I won't disclose it. Okay. So I'll just set this up, and you guys just join. Okay. I'll just wait for you guys to join. See the young coder. So I'll tell you the one thing that I think you guys can't see my comment section, right? You guys can't see my comment section. So, anyways, I can see it. So, I'll just explain the whole thing after the contest gets over. Okay. So yeah, I stopped. Like, I don't know whether you should call it cheating or not, but yeah, whatever it is, I stopped it. Okay. So I'm waiting for everyone to join. Okay. So it's a mild request that whoever is watching this, just go on like whichever channel you are on, just go over there and just tell your friends to watch this video. Let's share with them. And since like at this moment I'm having a slightly lesser reach, so I'll just request you that if you guys can subscribe my channel. Okay, bro, you don't have to delete it. Okay, the young coder, you don't have to delete it, it's okay. Okay, the 3 people are watching right now, so it's 10:19 almost. So after a few minutes I'll start with the whole thing. Okay, I'll start with it. I mean after yeah, I'll start it at 10:22. Okay, somewhere near 10:22, because I need like people to join so that the explanation becomes much more easier, right? So I'll just wait till 10:22. After that I'll start. Hi man, hi. Okay, so the contest is over, right? So the contest is over. So just wait for a few minutes, just wait for 2 minutes. Let people join so that I can start with it. Okay. Just wait for 2 minutes. Okay. It won't be too long. Just wait for 2 minutes. How to start CP? So if you're starting CP, it basically means that what do you mean by starting CP? Like at which state you're right now? Okay. So if you're a beginner, like if I'm considering that you can solve, uh, let's say you can solve 3 questions on. I mean, if you're a beginner, you can solve 2 questions. Then you are 2 questions on lead code. Then you're considered as an intermediate. Okay, like just tell me how many questions did you solve today. So based on that, I can give you a kind of roadmap. Okay, based on that, I will give you a roadmap. Yeah, I'll answer it. Just tell me how many questions did you solve today, because if I don't know like at which level you're right now, so I can't tell you, right, like how to prepare yourself, because there are various levels, right? There are various levels. Like let's say you are at level 1, at level 2. So if you're at level 1, I'll just tell you how to get to level 2, right? If you're at level 2, I'll tell you how to get to level 3. Okay, so that's it. I'm just asking you like how many questions did you solve today, in case if you have given the code forces thing. Otherwise, if you have not given, I'll ask you like how many questions do you usually solve on code forces or lead code. Just give me a rough approach, like how many questions as an average you can solve. Okay, so based on that, I can give you a solution. I hope that is clear, right? Bro, I'm not getting any response from your side, and I'm just assuming that I'm not lagging. If I am, you can like tell me if I'm lagging anyhow. But I'm just assuming that I'm not lagging, okay? Because from my end, it's perfectly clear. It's perfectly clear. The network speed is perfectly clear also, okay? So, can you guys hold for a few minutes so that I can just go on and edit the thumbnail, and then I just post the thumbnail. So since it is almost 23, so you guys can wait for a little bit more. Okay. So I'll just post the thumbnail, and after that I'll just go on with the solution. Okay. So before that, let me tell you that I haven't done all the questions, but I'll try to check the editorials. Okay, I have done till F. Okay, till A to F. So I'm just telling you beforehand this. Okay. Because later on you may come like, bro, you told that you're going to solve the whole thing. So yeah, I don't solve the whole thing. Can anyone tell me like how many people are there? Like, are the people waiting? Like, are the people have joined already? From my end, it's showing that there is 0 people. Okay, like, I mean, just one watching. That is me, I guess. I don't know. There may be a glitch. So if you have joined, just give me a thumbs up. Okay, just give me a thumbs up in the live chat so that I can just start with the video. Okay, just give me a thumbs up. Okay, bro. Anyways, if I don't get any response, okay, so I'll just start with the video. If I don't get any response. Not much people have joined, I guess. So guys, just join as fast as possible. Tell your friends to join. Okay, so that we can start with the video. Well, I feel like I should start with the video, okay? I'll start with the video. Just let me make the thumbnails. Just let me set the thumbnail and then I'll start with the video. So, okay. Make the thumbnails. Just let me set the thumbnail and I'll start. Okay, so someone is over here. Just whoever is over here, just can you tell me like if I'm perfectly audible and visible? Okay, because I'll just start with the video. Okay, just give me like just quickly tell me whether I'm audible and visible. Just tell me if I'm audible and visible, okay? Because from my end, I feel that there is no lag. So just quickly tell me. Because I feel like I've been waiting for too long, so I'll just start with the video. Very soon. First, let me just set the thumbnail and then I'll start, okay? Just please bear with me for a few minutes. Rather for a few seconds, just bear with me. I don't know what the heck is wrong with this. Okay, so okay, so I'm audible. I guess I'm audible and I'm visible. Okay, so I'll be starting with the video. So let's get into the first question. Okay, let's get into the first question. So if you look at the first question was very simple. They stated that so if you look at the first question. Okay, so I'm perfectly audible. Okay. So it is stated that today's Sakurako has a math exam and the teacher gave the array consisting of A1s and B2s. What he can do is he can either place a plus or a minus in front of each element so that the sum of all elements in the array is equals to 0. Okay. So what he can do is basically, let's say, like, let me go to this. Okay, let me just go to this and I'll just explain you how he does that. So before that, just let me check, like, I think not much people are there in the chat, so I'll just request you guys, just please join as fast as possible. Okay, so that I can, like, so that the thing becomes quite interactive. Get it? So let me keep the window projection over here so that I'll get a idea about how much of the area this thing is taking up. Okay, so let's I'll just go to the Excalibur thing. Okay, so let's say we have got a number so let's say we have got a number of ones. Okay, a number of ones and b number of twos. Now if the number of a and number of b, that is the value of a and value of b, if both of them are somewhat, let's say if both of them are somewhat even. Okay, if both of them are even, so what we can do is, let's say they are even number of ones. So if they are even number of ones, so we can just put the plus and minus alternatively. So first there will be a plus, then a minus, then a plus, then a minus. Okay, and similarly for 2 also, if there are even number of 2's, so we can do that. Now let's say the main thing, the main problem that we have to face, okay, the main problem that we will face is when sorry, the main problem that we face is when the either the count of a is odd or the count of b is odd. Okay, now let's say if count of a, okay, so let's say the count of a is odd. So if count of a is odd, what we can do is, let me go to this thing. If count of a is odd, we are left with only one, like the remaining of the ones has become zeros. Okay, so we don't need to check them, we are just left with only one. And if count of b is odd, so we are left with only 1 2. Okay, now if we are left with only 1, in that case what we can do is we can just, like, we can't ignore that. Okay, so what if we are going to take out 1 2 and we are going to, like, keep, if we are going to increase the number of ones, so we can just remove the last two elements, last two ones that has occurred. Okay, and on the basis of that, what you can do is you can just check the number of 2's on the basis of that. Okay, so no matter what we do, so let me just open this also. Okay, so no matter what we do, if the number of A's, the number of ones, if it is odd, you can't have any possibility of making the sum as 0. Okay, at any position you can't make the sum as 0. Clear? But on the other hand, if we see that if the number of 2's, it is odd, so we are left with one extra 2. Now let's say, now we are going to consider this situation. Okay, now we are going to consider this situation. So let me just erase this. Sorry, I'll just erase this also. Okay, now if we are going to consider this, that is, it was already 0, but from this you can take these two out. Okay, these two out and make this plus. So basically, in spite of plus 1 minus 1, which was actually 0, we get a 2, right? We get a 2. Now this 2, if we subtract from this 2, then also we get a 0. So the thing is very simple. What we basically do is, whenever we are finding that, whenever if we find that if something happens in such a way that so if both A and B are having both A and B is even, in that case it's a complete yes. Okay, it's a complete yes, so you can make the sum as 0. But if either of A and B, any one of them is having an odd number, so then there will be some exceptional cases, or at most it may happen that it will be a no. Okay, so if A is going to have odd, is A is odd, so we can directly say it's a no, because if A is odd, so we are left with only 1, right? And you can't, like, whatever you do with this 2, you can't ignore this 1. But if B is odd, so you're left with only 1, 2. Now this 2 can be formed by 1 plus 1, right? So basically, in order to neutralize this extra 2, you need at least 2 1s. So if A is at least twice, okay, if the value of A is at least 2, then only we can neutralize it. So I'll just go with the code. Okay, over here what I'm doing is I'm just taking the inputs A and B, and then just initially the answer is no. Now if A mod 2 is equal to 0 and then B mod 2 is equal to 0, so in that case what we can do is, let me do one thing. Let me just pause the stream for a few minutes. I think it's getting too boring, man. No one is over here. I see no people over here. Chat, can you just go and like tell people to join this as soon as possible? Because I feel like it's getting too boring. Like I am explaining the whole thing just live and I don't feel like... Anyways, I can explain it. It's not much of a big deal. Okay. So from my end it's showing now there are 2 people watching. So whoever is watching, just be responsive. Okay, just be responsive. I'm discussing the first question. Okay, in the first question, so as I was telling you, so if both of them are even, it's a complete yes, because we can neutralize both 1 and 2 individually. Now let's say if A of else if B is even, B is odd. Okay, B is odd, but A is even. So in this case, it will be only possible if there is at least greater than 1, or let's say if there is at least 2 1s. Why is it so? Because I was explaining you this condition, right? This condition, that if you have a 2, so you will be needing at least 2 1s to make it 2, so that you can neutralize this 2. So in that case, you will need, if this is so, then answer is yes. And this thing, this was not needed actually. You could have also ignored that. Okay. Now, so that's it. So that's it. So if any one of you who is watching this have any doubt, just tell me. Okay, so for now no one is watching this. So I'll just go like to the next question very quick. Okay. So I'll just go to the next question very quick, real quick. This question is very simple. It is given that square or not, and it is given that you have a beautiful binary matrix. And what is a beautiful binary matrix? A beautiful binary matrix is a matrix in which all the edges, okay, all the edges are 1, but everything inside is 0. Okay. So you are represented that using a string, that is the string is like 1 1 1 1 1 1 0 0 0 1 1 1 1 1 1, something like this. Okay, so basically the string is traversing it throughout, like in this pattern, in this manner, and from that string you have to find that whether you can have a beautiful binary matrix which is also a square. Okay, so a matrix is square when the number of rows and number of columns is same. So over here, if you're considering this, okay, if you look at this 1 1 1 1, this is a beautiful matrix and this is also a square matrix. But none of the other matrices are none of the other matrices are square, but they are beautiful. Okay, they are beautiful, but they are not square because the number of rows and number of columns are not equal. Here, now the string is always the result of writing out. Okay, so this is given that so you have a condition that the string is always the result of writing out the strings of a beautiful matrix. So using this, what you can do is, okay, still I think I got no viewers. Not much problem. It's okay. I'll just go. So what we do is basically for this. Now I'll just delete this and go to this. Okay. So let's say you have a beautiful matrix. Okay, you have a beautiful matrix. Now, if the whole length of this, if you want to make it square, now the string that you have made from that matrix, okay, the string that you have made from this matrix is going to have a length of n, and this length of n has to be a perfect square. Okay, so the first condition that n has to be a perfect square. Okay, so n has to be a perfect square, and after you're done with this, what you can do is you can now construct a matrix, a beautiful matrix of size n into n, and store it into a new string. Let us call it mod. That is a modified string. Okay, and after you're done with that, you have to just check whether the mod and the string that has been given as the input are same or not. Okay. So I won't ask that whether it's clear or not because there are not much people over here. So I'll just assume that it's clear. So I'll just go with the code directly. This is the reason I feel like I shouldn't, the basic reason why I feel like I shouldn't record and upload videos, and rather I should like go for live streams, and I feel like you guys are not that interactive. Okay, so I'll just ping again on my server. So I'll just ping on my server, just hoping that people will be joining. But anyways, I can't force people to join. Actually, there's one thing that there are many like streamers who stream. Okay, so so that makes it difficult for streamers like us. So anyways, so this is what I'm meant to say. So now I'm just assuming that you guys got it because there is no much response from you guys. So just I'll go with the code. So I'm taking a input of n, then I'm taking a string and taking the input of string, and I'm first checking whether the n is a perfect square or not. So this is the condition to check it, and if it's not a perfect square we can directly return no. Okay, and then this modified string. Now I'm just rewriting nn. I'm just taking a variable nn which is the square root of n. So basically now we are going to construct the beautiful matrix. Okay, so in the beautiful matrix you know that the first row and the last row, okay, these are the first and the last row, they are going to be all 1, and for the remaining rows from 1 to n minus 1, the first element is going to be 1 and the last element is going to be 1 and the remaining elements is going to be 0. So once you have constructed the whole thing, so you have to like check if both of them are equal or not. If they are equal, you can return yes, and if it's not so, you can return no. Okay, I hope this is clear. I just have to assume that it is clear because I don't think anyone is joined. The chat is perfectly working, but anyways, I'll go to the third problem. Okay, so let me go to the third problem. Okay, so I'll just quickly go to the third problem. I think I should like stop streaming right now. I just go fast forward through all the problems because I'm not getting motivated enough. Okay. So today Sakurako was studying arrays, and array A of length n is considered good if and only if array A is increasing, meaning that it is strictly increasing. Okay, whenever it's told that it's increasing and this condition is given, it means it's strictly increasing, and the difference is also strictly increasing. Okay, and the difference is also strictly increasing, and you're given a value of the boundaries, that is L and R, and all the array elements has to be within the range of L and R. And what you have to do is you have to find the maximum length of the good array for the given value of L and R that has been given in the input. Okay, very simple approach. So what we have to do is, so let me first delete this. So let's say you have got a L and you have got the R, and all these elements has to be well within this limit. Okay, and whatever it is over there. Now if this is L, the next element can be L plus 1, right? And the very next element can be L plus 1 plus 2, right? Because like it has to be increasing, so first we increase it with 1, then we increase it with 2, and then it goes on. Okay, till we reach a R, where R is basically equal to L plus 1 plus 2 plus dot till some value, let's say x. Okay, now this value this value we have to find out. If we can find out this, so we can find out what will the value, what will the number of elements. Okay, but remember one thing, it may happen that L plus this whole thing may not be just equal to R, but it may be like it is greater than equal to, R is greater than equal to this number. Okay, so let me just erase this and this. Okay. So basically R is greater than equal to this number. Okay, now which means R minus L is greater than equal to this number. Now since we get the value of R minus L, we can get it from our input, so we have to just check what is the maximum number of X, what is the maximum value of X. Okay, so based on that we can get the answer. Now how we are going to find the maximum value of X, we can just you may think that we can just traverse for all the elements, we can just traverse and go on traversing till it, but that is a very bad approach that we shouldn't use, because it will give you a TLE, because L and R, they are of range 10 to the power 9. Okay, so you may have to go on till 10 to the power 5 or maybe more than that. Okay, so basically you may think that 10 to the power 5 is well enough, but since T is of 10 to the power 4, so in some cases it may give you some TLE, because it's not 10 to the power 5 exactly, to be very much exact. If you're going to consider how many number of this answer, it can be of range 2 into 10 to the power 5. Okay, I can prove it. So that is because like the number of elements. So if you're going to consider this, so basically the sum of this element is going to be x into x plus 1, x plus 1 by 2. Okay, now based on this, x into x plus 1 by 2, so based on this, what we can do is, okay, just hold for a few minutes, for a few seconds. I just give this to charge. Okay, yeah. So what basically happens is this R minus L we know, so from that we can draw this, and you know that x into x plus 1. So let's consider that it is, this whole thing is x plus 1. Okay, x plus 1 whole squared. So that is x plus 1 whole squared. Its maximum value can be 2 into 10 to the power 9, right? Now if we have a square root of 2, it becomes 1.4. Okay, basically 1.4 into 10 to the power of 4 by square root of 10, which is somewhat maybe 3, I guess. Okay, so basically whatever you're going to get the value of x, okay, this is going to be the value of x, the maximum value. So it may happen that there will be some TLE. Okay, so it's better to avoid that approach, and you have to find x by using binary search. Okay, so what you can do is you can find the low, you can have a high, and for every specific element from low to high you have to find which value of x satisfies, and thus you can get the answer. So I'll just go through the code very fast. So I'm taking the answer as initially 0, and this is the difference, R minus L. Now low is equal to 0 and high is 2 into 10 to the power 5, because for safety you can just keep it 2 into 10 to the power 5, because 10 to the power 4 will also work. So basically mid is equal to high minus low, which is basically low plus high by 2. Okay, so after that we are going to find the sum of all the elements for first mid elements, and you have to check whether this sum is lesser than equal to diff. So if it is lesser than equal to diff, so you know that it can be a valid answer, and low is equal to mid plus 1. That is what we do in the binary search. Okay, and once you're done with it, so you should know one thing, that no matter whatever is the difference, so there will be at least one element, okay, because that is going to be L, and then the remaining element is contributed by difference. So this plus 1 is basically the L, and then you just get the answer. Okay. So you can see that it passed. So let me just take out this C and just go to D. Okay. So I don't think many people are like, this live is going like with 0 views. With almost 0 viewers. I don't know what is wrong with this live. Maybe this live hasn't reached that much people. So it's kind of demotivating, okay? I hope you get it. It's kind of demotivating. So anyways, Sakurako's hobby. For a certain permutation P, Sakurako calls an integer j reachable from integer I if it is possible to make I equal to j by assigning this thing. Okay, so this was basically, I won't explain the whole question in details. I'll just tell you like what you have to do is, I mean, you had a permutation, and from the first element you can go to third, from the third element you can go to the sixth, from the sixth you can go to the fourth, from the fourth you can go to the first. Okay, so basically these are the roots. These are the roots. That is from first to third, then third to sixth, sixth to fourth, and now from fourth it is reachable to 1. Okay, so basically from 4 we get back to 1, so we are not going to consider because now it has formed a circle. Formed a cycle. Okay. So Sakurako defines the function f of I as the number of black integers that are reachable from I. Now what is black integers? Among all these elements, there are few elements which are marked as 0. Okay, and few elements which are marked as 1. So what Sakurako have to do, he has to just consider the elements which are black, that is, which is having 0 in it. Okay. And few elements which are marked as 1. Okay, so let me go to the drawing thing. I'll just explain you real quick. So let's say you have the array, okay, you have the array, or let's say you have the permutation, okay. So in this permutation, what you can do is, you can start from the first element, then you can go to some other element, and whichever element it is pointing to, you can go to that element, then you can go back to some other element, and then that element can come back to the first element again, okay. Or it may go back to some other element also. It may go back to this element also. Okay. So if it goes back to this element, then this element will come back to this. Okay, because it's a permutation. So basically you are always receiving a cycle for every operation. So what you can do is, you can take out a set where you can insert all the nodes. Okay, you have to insert all the nodes. Now once you have inserted all the nodes in it, so now it's very clear that what we can do is, we have to just go on with the first node and perform the DFS. Okay, and perform the DFS. How are you going to perform the DFS? As I told you, that go from here to here, and then whichever it is pointing, then go from there to there, and just go on doing that. Okay, so you just get it, and in this DFS, count how many number of black nodes that you're getting. Okay, how many number of black nodes you're getting. Now based on that number of black nodes, for every DFS traverse, like all the nodes that you have traversed in this DFS, you're going to assign the value of this black to them. Clear? Which is very simple. Like if you want, I can explain you with this example. So if I'm having this thing 356124, okay, if I'm having 356124, what I can do is, like, for this, from here I can go to here, then from here, from here I go to here, okay, and this from here I go to here, and from here I go back to here, and from here I go back to here. Okay, now if I look at this thing 356124, that is this condition, okay. Now if I like put this thing underneath this, so it becomes easier for you to understand. So in this traversal, in this specific traversal, what we have traversed the first element, it was a 0, the third element, which was a 0, the fourth element, which was a 0, and the last element, which was a 0. So there were total 4 zeros. Okay, now since there were total 4 zeros, so let's say 1 2 3 4 5 6, so this was initially having a length of 6, right? So the answer will have a length of 6 too. So 1 2 3 4 5 6. Now for this, like for all the traversed elements, that is 3 6 4 and 1, okay, that is the first, third, fourth and sixth positions. It is going to be 4. First, third, fourth and the sixth position is going to be 4. Now you're going to traverse for the next elements, okay, you're going to traverse for the next elements. So let me just quickly erase this. I erased the wrong thing. Okay, so erasing that erases the whole thing, so I'll just go with, okay, so just ignore that. Now from 5, what we can do is we can go till here, from 2 we go back to 5, right? So this is a cycle. Now remember one thing, that we have already traversed 3 6 1 and 4. Now in this traversal we have traversed 5 and 2, and this 5 and 2, among this 5 was white but 2 was not white, it was black, so there was only 1, so it is going to be 1 and 1. After this we can say that all the elements have been traversed, so we can just simply ignore it, like for now we can ignore it, okay, ignore the rest, so we can just get out of the loop. So what is the answer? It was 4 1 4 4 1 4. Now if you check at the question, okay, it is also 4 1 4 4 1 4. So that is clear, I guess. So I'll just go with the code. So I'm taking a array n, taking the input, and I'm making it I of minus minus because it was 1 indexed. So I'm just converting from 1 indexed to 0 indexed. Okay. So I'm just converting it. Then I'm going to take a empty set where I'm going to insert all the elements, and I'm going to set the visited elements, like as I was doing, I was just cutting off them. So I'm just taking the visited elements, and all of them are not visited initially, and this is the answer that I have to return. So while the set is empty, what we can do is you can take a vector BRR, that is the elements that we are traversing at a specific time, okay, from a specific element, all the elements that we can traverse, so we are going to take them in this BRR. So first of all, we are going to take the beginning of the set in the BRR, okay, and then we are going to erase that from the set and make its value, visited value, true. Now this is count, this is basically count of black, okay. So S of value is equal to 0. So if it's black, so you are going to add 1 to the count, and value is equal to air of value, that is this is a DFS, okay, this is basically the DFS. Now while the value is not visited, so that is why we are not encountering a cycle, okay, while cycle is not encountered, what we can do is you can push it to BRR and erase that from the set, and just increase the count of black if it's a black and make the value to air of value, that is DFS. Okay, and then once you're done with that, now you're going to find, like, for int I equals 0 I year of size. So for all the elements that has been occurred in this cycle, we're going to give them a value of C, that is the count of black numbers. Okay, and then you're going to print the answer. So I hope this is clear. Okay, so no response, so I'll just assume that this is clear. I'll go to E. Okay, I have not done G and H, so I'll just go through E and F real fast and just end this video. This is getting too boring. So Sakurako loves alternate strings. He calls a string of lowercase Latin letter an alternate string if the character is at even positions are the same, if the character is the odd position are the same, and the length of the string is even. Okay, so this is one condition that you have to take into consideration, that the length of the string is even. So what he can do is he can either choose an index and delete the ith character, but he can do it no more than one time. So basically from here we can say that if n has to be even and if n is initially odd, then he has to do this. This is necessary. But if n is even, you cannot do this. You cannot do this. Okay. So this operation depends on whether n is even or odd initially. But the remaining thing, that's replacing thing, you have to do it. Okay. So what you can do is you can replace the element at ith position with some other alphabet or some other letter. Okay, so that's it. So let me go to the, let me just give you a explanation. So let's say we are just first considering that the value of n is even. Okay, so if the value of n is even, so we can't delete, right? We can't delete. Okay, this is the what array looks like. So for every even spaces, for every odd spaces, you can find the frequency, okay, and make it frequency of 1. And for these spaces, we can keep it as frequency of 2. Or you can do the vice versa also. Okay, you can do the vice versa also. Because I'll prefer doing the vice versa rather. So I'll just do this 1 and make this 2. Okay. So after that we can say that whichever is having the maximum frequency, like the alphabet which is having the maximum frequency in frequency 1, so we have to consider that alphabet and replace all the remaining alphabets. And similarly for frequency 2 also you have to do the same thing. Okay, so you can get the answer. This is for n is even. Okay, when n is even. Now what if n is odd? Okay, what if n is odd? In that case, for every specific position, what you have to do is you have to delete that element, and for the remaining part of the array, you have to just swap frequency 1 and frequency 2. Okay, so that is what basically happens, right? So if you're deleting one position, so the even positions, so only after that position, only elements after that position gets their positions, the parity of their position swapped. Okay, so the elements at even position comes at odd position, and the elements at odd position comes at even position. Clear? This is too humiliating, man. No viewers. Okay. So if n is even, that's it, and if n is odd, what you can do is, so for this case, for this specific case, what you can do is, whenever you're deleting an element, now you're going to use a little bit of concept of prefix and suffix. Okay, but you don't need to like focus on prefix and suffix much, because this is not completely prefix and suffix. Okay, so for this part, in spite of taking frequency 2 and frequency 1, what we can take is frequency 3 and frequency 4. Clear? So what we can do is we are going to take frequency 3 and frequency 4 for these parts. Now since we are taking frequency 3 and frequency 4, so now we have to do the alternative thing, that is append frequency 3 with frequency 2. and append frequency 1 with frequency 4, and the operation is same. Okay, the operation is same, that is find which is having the maximum frequency. You're going to keep that thing. Okay, the operation is same, but you're going to also remove this element. So you're going to remove this element from this frequency of 1 and frequency of 2, and once you perform the operation, now this window comes over here, right? This window comes to the next position. Since this window comes to the next position, so this deleted element goes on to frequency 3 or frequency 4, depending on whichever position it was having. Right? This is clear, I guess. So I'll just go through the code. It was Sakurako's hobby. DE. Okay, so this was E, right? So what I do is, like, I am taking frequency 1, frequency 2 and frequency 1, I am like putting it, and I am getting F1 and F2, that is the sum of all the frequency at frequency 1 and frequency 2, and the maximum MF1 and MF2. Okay, because we need them only. So after that, after doing this operation, that is, this is going to take the maximum MF2, the maximum frequency 2. Frequency is the sum of all frequency 1s, frequency 2, F2, and answer is n plus 1 because this is the maximum possible. Okay, so you can even take a value greater than n plus 1. So I'm just taking the greatest, that is for this is infinity. Okay, for this is infinity. Now if n is even, as I told you, you can say that for this part, that is how many, the maximum element, that is the maximum frequency of frequency 1 you have to consider. For the remaining elements you have to swap them, so F1 minus MF1, and similarly for the frequency 2 array also you have to do the same thing. But now again we are having this frequency 3 and frequency 4. So if this is n mod 2 is even, so I mean n mod 2 is equal to 0, that if n is even, so this is a perfect thing that you can do. But for if it is not so, what you have to do is you have to make frequency of 3 and frequency of 4, and for I is 0 to I less than n, if I mod 2, frequency of 2 and frequency of 1. Okay, so what this is a deletion. Okay, this part is the deletion. This part is the deletion, that whenever we are going to take that specific element, so we are going to delete that, and once we have deleted that, now we are going to append frequency 2 to frequency 3 and frequency 1 to frequency 4. After we have appended, now we are going to perform the same operation with frequency 3 and 4, whatever we have performed with frequency 1 and 2 earlier, and then we are going to find the answer. Okay, and whichever is minimum, I'm going to keep it. And then after you're done with it, so you have to, as I told you, now you have to take away the, I mean you have appended it, so now you have to re-append it. I mean just you have to take it away. Okay, just take the frequency 2 from frequency 3, and if I mod 2, then frequency 4 gets updated, and if not so, then frequency 3 gets updated. So this is basic operation. Okay, so that is E. I hope that is clear. So before getting to 7, so I'll just go through, I mean before getting to the F problem, I'll just give you like what the problem is all about. So Sakurako has a box with n balls. Each ball has its value. She wants to bet with her friend that if the friend randomly picks 2 balls from the box, it could be 2 distinct balls, but they may have the same value, the product of the values. So basically the product of the values will be the same as the number that Sakurako guessed. Now this is too they always give a too much better explanation, but we don't need to do this. So what we have to find the expected value of product of 2 numbers from the specific array, and whatever the expected value is, it can be like in the form of p by q. So you have to output p q inverse mod 10 to the power 9 plus 7. Clear? Very much clear, I guess. So let's say for this, I'll just go with one of the examples that has been given in the problem. So let's say for this, we are going to take this example only. So 3 to 3, okay. So for 3 to 3, 3, 2, 3. Now if I take this element, I can multiply it with 2 and multiply it with 3. So that is 3 to the 6 and 3 3 is a 9. Okay. And if I take this 2, I can multiply it with only 3. That is 2 3 is a 6. Now if I divide it with 3, that is, there are 3 possibilities. So if I divide it with 3, so we basically get 7. Okay, so we basically get 7. Clear how we get it? Now if you notice one pattern, so you have to find what this thing is going to be and this thing is going to be. Okay, so in order to find this thing and this thing, what we can do is, so I'll just drop this out. So you can see one thing, that whenever you're going to take 3, you're going to add, like you're going to multiply it with 2 as well as 3. Okay, whenever you're going to take 2, you have to multiply it with 3 as well as 3. That is the remaining 2. Now I didn't consider this 2 into 3 because this was symmetric, but you have to consider in your case, because that will be actually redundant, but that won't make any difference. Okay, that won't make any difference. So basically, like if you notice one thing, so for every specific element, what you can do is you can find, okay, no, I made a mistake. So you're going to consider this 2 with only this 3. Okay, only with this 3. Now what we basically do is, so let's say the sum of this whole thing, so it is 3 plus 3 plus 2, that is 6 7 8, right? The sum of this whole thing, it is 8. Now from 8, if we subtract 3, then we get this 2 plus 3. And you can notice one thing, that 3 gets multiplied to 2 as well as 3, and it gets plused. So let's say, for the, we know the formula that AB plus AC is basically A into B plus C, right? Now since this is the formula for this, so what we can do is, we can remove 3 from this 8, which gives us 8, 7, 6, 5, right? We get 5. Now we can multiply 3 with 5. So in spite of making it 6 plus 9, we are just going to multiply 3 with 5. That is, instead of making 3 into 2 plus 3 into 3, so just let me change the color. Okay. So in spite of making 3 into 2 and 3 into 3, what we can do is, we can make 3 into 2 plus 3. Okay. And then similarly for this 2, we can make it 2 into 3. So now from this 5, we again cut off 2, which makes it 3. Now we have to multiply this 2 with 3. Okay, so basically 3 into 5 plus 2 into 3 plus 3 into 0, because if we like cut off this, so 3 from 3 becomes, if we cut off, it becomes 0. So if we multiply them, so 3 into 5 is 15, and 15 plus 2 into 3, that is 6. And if we divide it with 3, it becomes 7. Okay, clear? So basically this is what the approach is all about, and this is basically NC2, because we are only considering 2 elements from n elements. This is NC2. So I'll just go with the code real fast. So let's say we have taking this array, then sum 1 and sum 2, it's not necessary. Okay, this I was having some other approach, that is the value of expectancy, the expected value. Okay, I was having the expected value formula, which states that expected value of x squared minus expected value of x whole squared, like something like that. Okay, so that formula, you don't have to consider that. So I'm just taking this sum 1, the sum 2 is not needed. Okay, the sum 2 is not needed. Now for int I is equal to 0 to I less than n, I plus plus, now you're going to input error of I, and sum of 1, you're going to add that to it. Okay, and p is basically the p by q form. It was in the p by q form. So p is basically the p, the numerator. The numerator is going to be sum 1 minus error of I. So that is, we were subtracting this present element from the sum and then multiplying it with the present element. Okay, and this is the mod thing. Okay, this is the mod thing. So we get the p value of p, and the q value is nc2, so that is n into n minus 1 uh, by 2. And it's okay. No, I made a kind of mistake. It's not going to be nc2. Okay, it's not going to be nc2. It's going to be n into n minus 1. Why is it so? I'll also explain. This is the problem that occurs. Like, I didn't even know, like, this thing went out of my screen. So did I just, okay, I made a, like, I took up this area, right? So anyways, this is the problem when people are not live. Lack of interaction. Anyways, don't worry much about that. So what happens is like n minus 1 mod. So why is it so? Because if you're choosing only two elements, so let's say we have got n elements, so just taking one element from here, it gives us n opportunities, and then taking another element, it gives us n minus 1 opportunities. Okay, so it is basically n into n minus 1. Clear? So basically we do this, and then q inverse is mod exponential of q, and then we make p, and q inverse we multiply it and make it mod. Okay, and the mod pow thing looks somewhat like this. So this is what we also somewhat call bin pow. Okay, famously it is known as bin pow function, and this is the mod exponential function. So this is used for this mod minus 2. I use it for mat exponent. Okay, format exponential. And then this is the bin pow thing. So this is the basic code. I think you guys have already come across this. This is very famous in competitive programming. Okay, so that's it for F. So no one is live, like no one is watching this video right now. Okay, you guys have already come across this. Yeah, so no one is watching this video right now. I'll just end it. So that's it from my side. Thank you.